Welcome to the 59th episode of the New Ventures podcast. I'm your host, Sanjoy Sanyal, the founder of Regain Paradise, a boutique climate finance firm and a visiting fellow at the Cambridge Judge Business School. In this special series of our podcast, I explore the applications of artificial intelligence in climate solutions. Our guest for today is André Ferreira, data scientist at TransitionZero, an organization which uses open data products to help shape a clean energy future. Welcome, André.
Thank you, Sanjoy. Thank you for the invite. Great to be here.
Let's start off by obviously a personal introduction. Please tell us a little bit about yourself.
Sure. So, as you said, I'm a data scientist at TransitionZero. And so I mostly work on the machine learning side of our work, basically trying to provide the data that will be used internally at TransitionZero to drive our insights and our impact, and also towards open data projects that we make available for the world. So this includes projects like estimating greenhouse gas emissions of coal power plants, mapping out solar panels and other grid assets, and lately as well, extracting other power sector knowledge via large language models. And outside of this career side of my life, I have a master's in electrical and computer engineering from the University of Lisbon.
Was this your first job, or what drew you to this organization?
Yeah, I've always had an interest in contributing in some way towards sustainability and addressing climate change. I did that electrical engineering course over in Portugal. And throughout that course, I tried to get my feet in some of these initiatives. For example, I did an internship trying to investigate how to have safe nuclear fusion reactors. And in following internship, we worked on predictive maintenance for wind turbines, so trying to optimize renewable energy. But yeah, this role as a data scientist at TransitionZero is my first full-time role, and I'm very happy with what we've been achieving there.
Wonderful. And you have obviously started talking about what you do in TransitionZero, but just to introduce your organization, a little bit about the genesis, who your colleagues are a little bit, and who your funders are.
Sure, Sanjoy. So it's a non-profit organization from London in the UK. We started in beginning of 2021 as kind of a spin-off of a different climate organization called Carbon Tracker. And yeah, our main purpose here really is to provide open data products to partners and decision makers so that we can shape clean and fair energy future. At the moment, this purpose we have of building this open source energy transition data platform and really become industry standard there so that we can help this important and complex process of planning out the journey to net zero.
And when you say open data, I know you use a lot of, say, satellite data to measure greenhouse gas emissions. I think it'll be just useful as we get into understanding what you do, just to understand what this use of satellite data means.
Sure. For example, taking the case of our work with Climate Trace, where we're monitoring the emissions of coal power plants. What we do is we first need to get data to train machine learning models. So, for example, for regions of the world like the US, Europe, and Australia, we can get reliable and granular power generation and emissions data. And from that point, we can match those with satellite images of each power plant, which can be used to train these models to predict emissions. So, for example, a model will learn that a large plume coming out of a cooling tower or a flue stack of a power plant can be related to X amount of CO2 emissions. And in terms of the actual satellite data that we're using, we use a combination of different satellite constellations from Sentinel-2, Landsat-8, and Planet as well. And yeah, this is a process of getting the images of the right time and right point in the world. And we mostly use RGB bands, so basically the visible light that we get out of their sensors, as well as some other bands like infrared and, in the case of Landsat, thermal data as well.
Great. Just to put it in very simple terms, you have a database of actual reported emissions. You map that against the satellite images of the plants. So that's a database which the machine learning algorithms use to be able to predict emissions where the reported data is not easily available. That's the way I'm interpreting it. Is that right?
Exactly. Yeah, because outside of those regions I mentioned, like Europe and the US, it's harder to get a hold of data if it even exists at all. So we apply what these models learn from those regions to the rest of the world. In some cases, we can also not just blindly trust the outputs as it is, but let's say, for example, China does report aggregate emissions. So let's say monthly emissions of an entire region of the country. We can still validate our results as we also aggregate to compare our own outputs.
Right. So you can use this algorithm, so to speak, to be able to estimate emissions, right? And then validate reported data. Let's talk a little bit about the satellite images that you mentioned. You mentioned, just trying to simplify this for a non-technical audience, you mentioned different types of satellite images, and in some cases you're using visible light coming out of the power plants, and in some cases you're using thermal, getting a heat map, so to speak, right? Just can you help us understand this for somebody who, let's say, has high school knowledge of physics and chemistry?
Yeah, sure. Basically, when it comes to the emissions of power plants, we've seen that visible light is mostly enough, really, because what really matters there is the presence or not of plumes, so smoke coming out of the chimneys of the power plant. And the size of that plume tends to also correlate with how much power is being generated and how much emissions is coming out of that power plant. But then, of course, as well, when a power plant is operating, it tends to heat up. And in particular, the smoke, the air coming out of the chimneys of the power plant will be very hot. So that's why thermal imagery can also be useful there.
Yeah. Would it be correct to say that satellite imagery is available for all plants across the world, irrespective of whether data is reported from those plants or not?
Exactly. That's one of the big advantages of satellite data, because if we could have sensors in every single power plant all over the world, that would be perfect. But it's very hard to scale and very hard to maintain and also very costly. So the idea is that we already have all of these satellites constantly taking pictures of the world, and we can just rely on those to quickly scale to the entire world, whatever project we want to do, whether it is estimating the emissions of power plants, or even, mapping out different infrastructure that we care about.
Well, that makes it somewhat easier. Let's move on. You use this data for what you call the Future Energy Outlook, which provides net zero transition plans for countries. And that's obviously extremely exciting. But what I found a little puzzling is that greenhouse gas emissions don't only come from coal plants, right? So when you say power plant, are you kind of only talking about coal plants? I suppose there are other types of gas plants, and then there are other sources other than energy as well.
Sure. There's kind of 2 points to that question there. I guess speaking first on the side of the emissions, there's naturally a lot of emissions from other sources. Of course, you have gas power plants, you have oil power plants, and even outside, of course, of the energy sector, you have other areas such as land use, transportation, shipping, all these things. For other sectors, first of all, it's relevant to mention that Climate Trace as an organization has other groups that work on estimating the emissions of other sectors, because naturally every sector has a lot of complexities and different types of signals to look for. But then switching over to FEO, the Future Energy Outlook project that we're working on, this is a project where trying to look into the future, look into how countries should adapt and do their energy transition, while the emissions project that I was talking about is more focused on the past and present, right? So what are the emissions right now? With this energy systems modeling, looking into the next few decades, it's more important to know, for example, what is the current energy mix and how could that evolve over time? And thus, what is more useful here is looking at things like what is the total capacity of solar right now in this country, or how many substations and transmission lines are connecting this grid with another part of the world. So that's where we're working in that sense.
Well, that's very interesting, but I think I'll have to get into a little bit more detail. First of all, I think it'll be just useful for us to understand that the emissions project that you're looking at, which is where you said you're looking at current and past emissions, is that from all sorts of power plants, or is it only from coal power plants?
We do model gas power plants as well. I must say that coal power plants is kind of a lower hanging fruit in the sense. They're the largest source of emissions within fuel types. And also because they're slow to ramp up or shut down in that sense. So it's more clear to know these trends of when they're operating, when they're getting out emissions, and when they're completely turned off. So our main focus has been on coal power plants because of these modeling efforts and also how big of an emission source it is. But we do also model gas power plants.
And then on the future energy outlook, I think I'm getting a sense of what you're trying to do there, trying to model what the emissions of a country could look like using different energy mixes. But maybe you can just help us understand how you do that.
Yeah, we have these energy systems models. So essentially what it's doing is it's taking into account different types of assumptions, such as what is the current energy mix, what are the emission factors of each type of fuel, and other factors such as what does the current grid look like and what are the interconnections within that grid. And kind of talking more on why we're actually doing this. Energy systems modeling has been an important factor throughout the last decades already, but it tends to be kind of a closed model that, for example, a big consultancy group might do for a country. It is hard to scale, and it becomes also a costly project for, let's say, a developing country or a smaller region of the world. So what we're trying to do is combine these machine learning efforts, the open data projects we have, and make the energy systems models themselves transparent and open source. And this way we can provide access to these tools with higher quality data and without barriers of usage to a lot more people and a lot more decision makers.
Great. And since you have talked about two organizations, TransitionZero, which is the one you belong to, and Climate Trace, which you're a part of, which seems TransitionZero is a part of Climate Trace, just help us distinguish these two organizations.
Sure. So essentially, TransitionZero is its own organization, this nonprofit from London, as I mentioned. And Climate Trace, in a sense, is one of our many partners. So essentially, Climate Trace is a coalition of different organizations, from think tanks to startups and others, that are all working together towards this goal of accelerating the net zero transition. And kind of each organization inside Climate Trace is responsible for monitoring the emissions of a specific sector of society. And from that point, we can publish that data and make it open, as we've been doing. So in this case, just to make that clear, TransitionZero is responsible for the estimating the emissions of the power sector.
Great. Let's move on. The future energy outlook, which I actually looked up on the website, what I found interesting was that you've almost built it like an open source software, something like Red Hat Linux, or I used to work in e-learning earlier. So like a Moodle, which is an open source learning management system. What is the vision and where you want to take this product to?
Sure. Thinking about this, why we do it in this open way and making it open source, like you mentioned, it comes a lot with the purpose we have, what we want to achieve in terms of impact, and also what we want for TransitionZero as an organization. So in terms of impact, I think it's clear that old model of doing closed energy systems modeling and keeping it confined within expensive consultancy groups or other organizations, it becomes much harder to actually help those that need access to tools, need access to data to plan out this very complex path to net zero, right? So What we want with this open approach is to remove barriers of access, to really be able to provide tools for everyone, and really everyone, including Global South and countries that are most affected by climate change. And also by keeping it open, we also gain more trust in the results of these models and gain more trust in the overall methodology because it's open, right? It's transparent. Everyone can go and check and validate how it's working, right? And for TransitionZero itself, we've seen a lot of cases where open source has become the state of the art, has become an important part of everything. So from internet protocols to even now, in a sense, AI is relying a lot on open source as well. And so we want to become the industry standard, the kind of the leaders within the access tools of planning the net zero transition. And we want to become the leaders of this open energy systems modeling ecosystem.
And part of the success of any open source platform is the network or the developers that the platform attracts. How much progress have you made in that direction?
Yeah, so currently we're trying to build on network effects. So we want to build it in this open way so that we can really bring in data from our partners and get contributions from others in the modeling community. But yeah, speaking about how we deal with partnerships and users of these tools, we have, for instance, this new partnership with the World Resources Institute, the WRI. And there we're planning on working with them on country level energy transition modeling in Africa, starting with Ethiopia and Kenya. There's been some modeling of African region energy transition, but it's always been on the continental level. And that leaves a gap of information for the country policymakers and can also, ignore certain aspects such as energy security and the affordability of all of this. And we also have an exciting partnership with V20, which is a consortium of 58 nations of developing countries. And these countries are particularly vulnerable to the impacts of climate change. And again, here with our Future Energy Outlook tool, we're supporting the development of their climate prosperity plans. So how they get to net zero in a way that also leads to economic growth and prosperity. And we already started contributing to these plans for countries such as Ghana, Sri Lanka, and the Maldives as well.
These are wonderful examples, and I would try and get into them in a little bit more in detail in the next part of the podcast. But just to stop for a minute and reflect a little bit on what you have said so far. You've said TransitionZero, your organization focuses, the way I have interpreted this is two main projects. One is the emission project of looking at the emissions of power plants, mostly coal power plants, which of course are an important source of emissions, but also gas power plants. And the way you do that in some ways is to look at existing publicly available sources of reported emissions coming from regions where validated data is released regularly and mapping that with satellite imagery that allows machine learning algorithms to estimate emissions in places where data may not be available regularly, or sometimes there could be questions about the quality of that data. You have then gone a step further and developed the Future Energy Outlook to build an open source data platform where organizations can estimate net zero transition plans for countries. The point that you mentioned about energy modeling being a fairly practiced science, if you may, over the last decade, but being essentially closed systems, expensive systems run by very qualified but esoteric consultancies with countries, and then nobody having necessarily access to that model to be able to question it or to be able to add to it. And so you kind of want to change the paradigm and build an open source platform which countries can use, first of all, inexpensively, and then perhaps in a more consultative manner to build future scenarios for themselves. Already the examples that you mentioned about using it in partnership with the World Resources Institute in Africa and climate vulnerable regions are already great examples. With that, obviously, I'm going to talk a little bit about your partnership with WRI. The countries where you're applying the energy planning model are very interesting countries. Ethiopia, for example, even today, has a fairly large part of the population which is not connected to the grid. Kenya used to have a large population which was off-grid, but has made a remarkable progress around connecting even remote rural areas to the grid. So does your planning, for example, include both this so-called off-grid and on-grid models of electrification? And within off-grid, for example, does it also include solar home systems and mini-grids? Just give us an insight into what the modeling is all about in Ethiopia and Kenya.
Sure. And I think that's a very interesting question here because, again, we were talking about how before energy systems modeling used to be more closed and more expensive and harder to question. There's also the case that it used to be much less detailed. So, for example, instead of modeling Kenya and perhaps considering a very granular electricity grid that they have, and even these off-grid systems you mentioned, they would potentially, just model Africa and kind of simplify it to just a couple of points, just a couple of nodes in that sense. So what we're trying to do here as well is not only make these tools open, but also make them more detailed, providing tools where you can model countries and regions of the world with more nodes, in that sense, more information about the topology of the grid in those regions. And because we also have these machine learning projects that are providing additional high quality data, we can know more, for example, about how many solar panels exist in Kenya, right? Perhaps there is a database somewhere that has information about that, but it most certainly is not up to date because in the specific example of solar panels, deployment is being very fast and it's hard to track everything. So that's also where our satellite data and our machine learning models are coming in, helping us get more high quality data and being able to do energy systems models that account for a lot more detail and the actual status of electricity grid.
Great. And just to move on to the climate vulnerable example that you gave, is it that along with your energy modeling, you're also incorporating socioeconomic data like income and perhaps even inequality data, things like that?
Well, we're mostly providing here the tools to be able to look into this energy transition. And in this sense, we can do estimates, for example, on how much money is required to do X investment. So, for example, we might look into perhaps this country could become net zero, could reduce its emissions by 2030, but that would be an incredibly high cost, right? So we can play around with how fast we want to go and also the budget that is available, right? So we provide these tools so that really the countries and the decision makers, knowing their budgets and what they can do, what they can afford, they can model in their own way and not have someone else come in and say, you need to do this by this date. So that's kind of what we're working with here.
That's very interesting because that speaks to the world that I come from, which is climate finance. But before I go there, apart from these relatively smaller countries like Ethiopia and Kenya, I know that you have done this type of modeling also for large middle-income countries like Indonesia and China. Is it somewhat different in these cases?
Well, in a sense, it's still energy systems model, so it's not too different. But of course, it is comparing, for example, Indonesia and the Maldives. It's a much larger region of the world. In a sense, represents a bigger chunk of the emissions. It has a large population with, it's trying to grow its population and also grow economically. So trying to fight poverty is an important aspect there, and the budget might be tight. And at the same time, a place like Indonesia has a lot of biodiversity that we want to conserve and protect. So it becomes a really interesting example of how we do the trade-offs of energy, of climate, and also of economic development and kind of preserving nature as well. We have to take some of those factors into account, but otherwise it's still kind of a similar energy systems model.
Well, again, speaking on behalf of a lot of people who struggle to understand artificial intelligence, let's just talk a little bit about the Indonesia example that you gave. This is a large emitter. It is a middle-income country, but has strong pockets of poverty as well, and is growing fast over the last decade, and it poised to grow fast as well. But at the same time has rich biodiversity, which the world needs to conserve. Is this all something that an artificial intelligence system can model, or is there some points at which humans have to intervene?
Yeah, that's a good question. I think thinking about energy systems models themselves, in a way, it's an optimization method that it takes into account any constraints and assumptions you want to do. So let's say that you want to have a constraint on preserving biodiversity. That could be some you could attempt to include in the model. And then thinking, for example, on how we use AI to do this, or perhaps how we think about capacity expansion, how you build new renewable energy or clean energy sources. This can be worked on, for example, let's say you map out the regions in the country that could be available to, for example, build solar panels or install wind turbines or even nuclear power plants. And what you can do is perhaps take into account what is the current land use of that. So, for example, you want to do deforestation to build more solar panels. Perhaps you'll allocate the solar panels to rooftops, or you'll place them even on top of bodies of water. There's a lot of things you can account for, and even switching to other energy sources, for example. But really, you can take into account these constraints in the energy systems models. And then you can also apply artificial intelligence to spot which areas are best for kind of this deployment of new energy.
I'm almost tempted to think that human beings can sort of build these constraints into these energy models. That's where human intelligence is used. And then artificial intelligence can be used to run these models. It can be used to spot spatially where solar panels can be installed. But perhaps there is the role for the human being also to interpret all this data and present it to a policymaker in easily understandable terms. Would that be a right sort of summary between this debate of what artificial intelligence can do and what human intelligence can do?
Yes.
Just getting back to the point about climate finance that you mentioned, obviously that has, in some ways, it's a very political topic because everybody wants to get more money for doing a transition in a certain time frame, if you may. Is it fair to say one of your goals is to take a little bit of opaqueness out of negotiation process and to bring some transparency into this?
Yeah, I think that's a fair way of putting it. Having these open tools can make it more transparent, and you can interrogate why we're doing these estimates. So, for example, if a country thinks we need to do the climate transition, but we don't have enough money, they can, for example, rely in these tools and provide the full explanation of how they got to that number, how they got to how much they need. And in a sense, I would say these kinds of tools, these kind of processes have already been done before for many decades. Not only in the sense of that process I mentioned of being more expensive and closed, but also by different energy companies and consultancies to expand, for example, fossil fuel energy projects. So in a way, we're kind of doing a similar thing, but in an open method, and actually trying to motivate and seed investments into clean energy and in a clean future.
Exactly. I think these are great examples that you provided. I think I'm going to take a minute or two to just reflect back on some of these things that you have mentioned. I think existing energy modeling techniques have been closed. That is something that we have discussed earlier. Sometimes they tend to be influenced a little bit by the agendas of organizations. And so using open source tools make things more transparent, make the negotiation process of estimating how much money is required to make a transition in a particular time frame more clear, and of course helps the transition towards a cleaner energy future. It is obvious to me that, from what you've described, the tools that you have developed tend to have almost a universal focus, because Indonesia, with its biodiversity and its a really fast growing, but still middle income country, is very different from Ethiopia and Kenya, though Kenya actually is also a middle income country, but very different contexts. You've done this type of modeling in China. Then you talked about doing this in climate vulnerable countries. So, obviously they have a fairly wide application across multiple geographies, which is a very powerful statement, I think, that you have alluded to. More countries should be picking this up, and with organizations like the World Resources Institute, which works with policymakers in many countries, that process of influencing policymakers becomes a little easier for a small nonprofit sitting out of London. We've come to the end of the podcast, so I'm going to just ask, do this is not easy, so perhaps give us a little sense of how you hire and what type of people are you having in your team?
Sure. I think for us, hiring is a lot about the talent, but also about the culture we want to have. So we want to build an organization that we actually want to work at, and one that is diverse and that respects the boundaries between work and personal life. And to strive to have a diverse organization, we also have a lot of processes to reduce our own internal biases. So we have a lot of automations, such as automating the time that a person has to complete a tech challenge, for example, making sure, no one will spend too much time on a tech challenge. And some people couldn't afford to spend that much time in a recruitment process due to care obligations or other situations in their life. Yeah, we have these graded assessments and also processes of trying to anonymize some personal information so that we can reduce our bias. We want to have this talented team that we are very fortunate to have, and that is diverse and without these internal biases. So just to give a few stats of our current team, we're currently 27 employees and growing very fast. That represent around 16 nationalities. And we have, I think, basically a perfect gender balance at the moment in the organization. So 50-50 between women and men. And we want to keep on building the team. We want to keep on growing to address all these challenges of the energy transition. And we want to preserve this culture of talented and diverse team.
And what do you mean by automating the time for tech challenge? Is it like when you're being hired, you're given a problem or a coding problem or maybe a Python code to write, and the time that you're spending on the test is monitored?
So that's, for example, when an applicant starts their challenge, after an X amount of time, it will close, basically. So there's no people involved. It's just an automated process.
If people want to get in touch with you, how should they?
They can reach out to me on social media, from LinkedIn to Twitter, just under my name, André Ferreira. And in terms of TransitionZero, they can access TransitionZero.org or also check out TransitionZero on LinkedIn and Twitter. We're available on those platforms as well.
With that, thank you very much, André.
Thank you. It was a pleasure.